Okay, the first thing that we're going to do is figure out how to turn our calculator back and forth from radian to degree mode. Okay, so you're going to go to mode. Okay, if you look at the fourth row, you have the option to be in radians or degrees. Okay. Whenever the calculator memory is reset, which I have my algebra kids do all the time, and they're in here before you, it gets automatically put on radians. So just make sure that when you grab your calculator, don't be in radians unless you want to be. So I'm arrowing down to the fourth row. I'm arrowing right to degrees, and it's not selected on degrees until I hit enter. Any questions about how to get degrees? Okay. Okay, cool. All right, let's look at our notes. All right, we're doing trig today. Ooh. Okay, so what we are going to do in geometry, it's trig, but it's special trig. It's going to be right triangle trigonometry. The trigonometry that has its own class or that you're going to do in pre-calc is like unit circle trigonometry. So you'll probably use this occasionally, but you'll also use the kind with the unit circle. If you have questions about what that is and what it means, I can talk to you about it later. I'd be happy to answer it, but not everybody's going to be into that answer. I can solve problems by using trigonometric ratios for acute angles, and we're also going to solve problems by using the inverse. Trigonometric ratios for acute angles. Okay, more on that later. Okay. Here we have a little blurb about trigonometry. The name comes from the Greek terms trigon, meaning triangle, which kind of makes sense, and metron, meaning measure. So the study of trigonometry involves triangle measurement. Does someone want to? So our trigonometric ratios are going to be ratios of our sides. So we're going to take two sides and make ratios. Now, depending on which two sides we take, we'll have a sine, a cosine, or a tangent. Okay? So let's look at this. This might help you guys out. Have you guys ever heard of SOHCAHTOA? Okay, so SOHCAHTOA is just a little acronym or like memory device to help you remember which ratios are which. Okay, so this is the first thing you're going to write down. Sine is the opposite over the hypotenuse. So we call that SO. Do you see the SOH? So, okay. Cosine is the adjacent over the hypotenuse. And TOA is tangent. That's opposite over adjacent. So that's going to help you remember which sides go into which ratio. Okay, so let's start with angle A. If I look at angle A, well, regardless of which angle I look at, the long side across from the right angle is always the hypotenuse. If I look directly across from angle A, I see side A. That's my opposite side. So if I wanted to make the sine ratio for angle A, it would be the opposite over the hypotenuse, or little a over little c. Does everybody see where that came from? Okay. Now, if I did the sign for B, angle B is this one. The hypotenuse is still the hypotenuse, but a different side is opposite of angle B. It's side B. So the opposite for B is going to be a different side. Everybody okay with that? All right. For cosine, actually, I might just want to redraw this triangle. I wish I'd given you this triangle twice. I'm sorry about that. I will fix it for next year, but it doesn't help you much right now. Let's just redraw this bad boy, okay? All right, so we've got A, we've got B, and I've got C, little a, little b, little c. Sounds like a rapper. Okay, so if I look again with my point of view from angle A, the hypotenuse is always the hypotenuse. That's the one opposite the right angle. Okay, little a, side little a is opposite. Adjacent, remember, means next to. So side B is the adjacent side for angle A. So the cosine for A is B over C, adjacent over hypotenuse. Everybody good with that? All right, the cosine for B is little a over C. Okay, you guys ready for the big brain moment? This is going to help you a lot in your practice. Otherwise, you're going to be like, I don't even know how to do this problem. It's not enough information. Okay, this is the big brain moment. Okay, if I'm working in the same triangle, my sine of A is equal to my cosine of B. Everybody see it? My sine of B is equal to my cosine of A. They make the same ratios. Okay, here we go. Tangent. All right, we're going to draw one more triangle here. This is our A, our B, our C. Here's our right angle. This is little c, little a, little b. Okay, the tangent ratio is formed by opposite over adjacent. So the tangent does not use the hypotenuse at all. So if I look at A, the opposite is little a, and the adjacent is little b. So it's little a over little b. Okay. If I look at angle B, the opposite is little b, and the adjacent is little a. Okay, what do you notice in the relationship between these two? What are they compared to each other? Are they opposites? You're close. They're reciprocal. Okay. Let's try a cute little example. All right, we are expressing these ratios as fractions and then as decimals to the nearest hundredth. Okay, so everybody's in degrees? Oh, we don't need degrees right now. Sorry, I had a brain fart. Okay, so I'm looking at angle J. This is asking me for the sine of J. So I'm looking at the opposite, and I'm looking for the hypotenuse. The hypotenuse is the 13. It's opposite the right angle. So the side that's opposite angle J is the 5, and then the hypotenuse is the 13. So would somebody give me 5 over 13 to the nearest hundredth? Okay. Great. All right, what about cosine of J? So if I'm looking at J and I want the cosine, I want the adjacent over the hypotenuse. So that would be 12 over 13. I'm getting 0.92. Okay. Now that I've mucked up my picture quite a bit. Tangent of J, tangent is opposite over adjacent. So the opposite side for J is the 5, and the adjacent is the 12. So that's 5 over 12. I'm getting 0.42. Okay, can you guys do them for K? Go. Okay, are we ready for the big brain moment? Yes. Okay, how do we know which one is opposite and which one? Just by the positions in the triangle. So if I'm looking at angle K, which side is across? Okay, so that's the opposite side. Okay, this one can't be adjacent because it's already the hypotenuse, right? So this other one has to be the adjacent. Did that make sense? Okay. Okay, you guys ready for the big brain moment? Okay, your sine of J is the same as your, your cosine of J is the same as your, and your tangent of your two complementary angles, they are reciprocals. So in this right triangle, if I have a right angle, which I do by definition, then the measure of K plus the measure of J, if you add those together, you have to get 90, right? So these two, whatever they are complementary. Okay? So this relationship is going to be true whenever you have complementary angles. Everybody cool with that? All right, here we go. Keep it moving. I apologize for where the hole landed on this problem. You have a hole punch hole right here, right? It's supposed to be sine. Would you just try to squeeze that in up above the hole the best you can? So this example requires us to use a special right triangle to find our trigonometric ratios. So we're just going to use the pattern. Okay, remember our 30, 60, 90 right triangle comes from an equilateral triangle where we drop a perpendicular bisector. We bisect this side and this 60-degree angle. So we end up with a 30-degree angle, we get a 90-degree angle. Do you remember how the pattern for our sides, what do we call our short side? X. And then our hypotenuse is double it. And then our long leg, x times root 3. All right. So, we are going to find that we will have the same ratios with the sides regardless of what the x is. So if I'm taking the sine of 60, that's I'm interested in the 60-degree angle. The opposite is x root 3. The hypotenuse is 2x. So it's x root 3 over 2x. What is going to happen to my cute little x's? They multiply together, or like they divide away, and then they give us a 1. So I'm left with the square root of 3 over 2. Okay. I messed up my triangle. X, 2x, x root 3. So we're going to try these over here. All right, what about cosine of 60? Well, the hypotenuse is still the hypotenuse. Okay. Cosine is adjacent over hypotenuse. So the adjacent side for 60 degrees is not x root 3, it's just this cute little x, the short leg, right? So I put x on top and 2x in the denominator because that's the hypotenuse. What does that simplify to? 1/2. Yeah. Okay, what about tangent of 60? Well, tangent is opposite over adjacent. So opposite was x root 3. Adjacent is just x. What happens to the x's? They cancel. They leave us with a root 3. Okay, do you guys think you can do the 30-degree ones? Okay, you got to switch your perspective and look at the other angle. So for the tangent of 30 degrees, we're doing opposite over adjacent. For 30 degrees, the opposite is x. The adjacent is the x root 3. Okay, the x's will cancel. Am I allowed to leave that radical in my denominator? No. So what am I going to have to do? Rationalize. So I'm multiplying by root 3 over root 3. Okay. So I have a root 3 on top, and then what's in my denominator? Root 3 times root 3 makes regular 3. Yep. Questions for me? Okay, your brain's exploding yet? Okay, we're doing great. Okay, we're finding lengths, and we are rounding to the nearest hundredth. All right, do you see that they have given us an angle? They've given us an angle and one of the sides, and we're finding the other side. So, let's go back for a second. No matter how long the sides are, the cosine for a 60-degree angle will always be this ratio. Because it simplifies to this every single time. So any angle that you put into your calculator knows what the ratios are for that angle because of similar triangles, okay? So we can use that fact to solve for unknown values in these cute little right triangles. So I look at my 60-degree angle, which is P. Where's the hypotenuse? The 12.9 is the hypotenuse. Ew. Okay, so with respect to the 60-degree angle, is the x the opposite or the adjacent? Opposite. Okay, so then I think using sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent, which of my ratios compares the opposite and hypotenuse? Sine. So the information in my problem tells me which of the ratios to use. So I say this: the sine of 63 degrees equals the opposite over the hypotenuse. So that's x over the 12.9. Now, in your calculator, this is a number. It's a number like a dozen or a league. Okay, it's a number. If you put in sine of 63 degrees on your calculator right now, your calculator knows what that is. Let's try it. So if I do sine of 63, this is the ratio that the opposite and hypotenuse sides make together every single time, no matter what. This is what they reduce to. Okay? So, if I'm trying to get my x alone, and this is just a number, how do I undo dividing by 12.9? I just multiply by 12.9. So I'm going to multiply on this side by 12.9, and I'm going to multiply on this side by 12.9 after I give myself a little bit more room because I planned this terribly. Okay, so these cancel. In order to find x, my opposite side, I just have to take the sine of 63 and multiply it by 12.9. So that's what I put in the calculator. I do 12.9 sine of 63. And it takes this number and multiplies it by 12.9. Did it say nearest hundredth? So 11.49. Okay. New triangle. Where's my hypotenuse? Yeah, my little side segment AB. This is the hypotenuse. Okay. They're giving me angle B is 15 degrees. Opposite of angle B is 10.2. So that's my opposite side. And then the X is my adjacent side. So which of my ratios is going to use the opposite and adjacent? Because I didn't use the hypotenuse at all. Yeah, the tangent. You guys are all right. So I'm going to say tangent of 15 degrees equals the 10.2 over the X. Okay. Find a spot where you have a little bit of extra room, maybe up there in the corner. I'm going to show you something right now that if you can figure out how it works is going to save you a lot of time and energy. So we're going to front load this and just go through the pain, and then it's going to be ours to use forever. Got it? Okay. So I have the tangent of 15 degrees is 10.2 over X. Unfortunately, my unknown is in the denominator, which is super irritating because I want it to be in the numerator so I can find out what the heck it is. Okay? So I can get this in the numerator by multiplying both sides by X. Do I want this number, tangent of 15 degrees over here with X, or do I want X by itself? By itself. So how do I undo multiplying by the tangent of 15 degrees? I divide it away. Okay, so now in the denominator, I now have where the X used to be, a tangent of 15 degrees. And these cancel. So I have X equals 10.2 divided by tangent of 15 degrees. Now, look at what I started with. Look at this equation. What happened? What happened to these two? They swapped. So instead of having to do this every single time, what can you do with these two? Swap-a-roo. Swap-a-roo. Okay, so what's happening here is that this is the numerator of that side. So you're swapping along that diagonal. Everybody okay with that? All right. So I'm sorry that that took a second, but in the end, I think that that saves you hours and hours and hours. So you're welcome. I regret nothing. Okay, so our X equals 10.2 divided by the tangent of 15 degrees. Okay, go ahead and ask your calculator what that is. I got 38.07. Is that what you guys got? And you are correct, it is feet. Okay, number letter C. Yep. All right, so they've given us angle F. Okay, where's the hypotenuse? X. Okay, so 20 meters. Is that the opposite or the adjacent? The adjacent. So which of our ratios compares adjacent and hypotenuse? Cosine is correct. So I know that the cosine of 39 degrees is the 20 meters over x. Oh no, my x is in the denominator again. What on earth am I going to do? Swap it. Swap it like it's hot. Oh, girl. You were waiting for that moment. Don't lie. Okay, so I've got 20 divided by cosine of 39 degrees. Ask your calculator what that is. All right, 25.74? Is that what you guys said? Okay. 25.74, 25.74. And these are meters. Did we have units on the first one and I skipped it? Centimeters. Busted. Sorry. All right. Let's do some word problems. This is so much fun. Okay. We have a ramp for the sister. The ramp is 12 feet. So the length of the ramp is 12 feet. Okay, it slopes upward from the ground at a 4-degree angle. We want to know first the horizontal distance. So which one are they calling the horizontal distance up there, the x or the y? The x. All right, so with respect to the 4-degree angle, what is the x? The adjacent, and the 12 is the hypotenuse. Okay, so I can say which of my ratios compares adjacent and hypotenuse. Yep, cosine. So I'm going to do the cosine for 4 degrees equals the adjacent x over the hypotenuse 12. So how do I find x? Yeah, I'm going to take this 12, I'm going to multiply both sides by 12, so it'll be 12 cosine of 4. Here, let me just rewrite that so it's not gross. X equals 12 cosine of 4 degrees. $11.97. Is this feet?
Yes.
Thank you. Okay, because that angle is so small, does it make sense that the long leg is almost as long as the hypotenuse? Think about it. It can't be the same as the hypotenuse, but it can be almost as long, right? Because the angle is so tiny. All right, what else do we have to find? What is the height of the ramp? Okay, so that's the y. So, x was the adjacent, what is the y? Opposite. Okay, so which ratio am I going to use? The sine, comparing the opposite to hypotenuse. So sine of 4 degrees equals y over 12. So y is 12 sine 4 degrees. This should be a really small number. Yep, 0.84, that's what I got. Oops, not degrees, those are feet units. Okay, so this is just a reminder about, like, make sure that you're in the mode that you want to be. If you want to be in degrees, make sure you're in degrees. If you need to be in radians, make sure you're in radians. Okay, if your answers aren't making sense, that's the first thing I check. Okay. Yay, it's another word problem. Okay, we want to find the length of the shadow. Okay, guys, where is the shadow? Is the shadow here in the air? Where's the shadow? On the ground. So this is our x. Okay? Make sure you put your unknown in the right spot or you're solving for the wrong thing. Right? Just saying. Okay, so where's my hypotenuse? In the air. Okay? So I have a 58-degree angle. What is this side? Opposite. And then my x is the what? Adjacent. So did I really need my hypotenuse? Which of my ratios compares opposite and adjacent? Tangent. So I'm doing tangent of 58 degrees. And it's opposite over adjacent. The opposite is 10. The adjacent is the x. Oh no, my x is in the denominator. What am I going to do? Swap it. Don't you love that? It was worth it, right? Some of you are like remembering my singing and my song and you're like, not worth it. Not worth it. Try to just block that part out. Alright, so I've got 10 divided by the tangent of 58 degrees. What, it was what? 10 divided by tangent of 58 degrees. 6.25. What are we rounding to? Does it say? Tenths? Okay, so 6.2 feet. Thank you. All right. We're going to stop here.